M5C2 test, circular motion, question number 8. A fairground wheel has a radius of 30 meters and rotates once every 80 seconds. So that's my radius, that's my time period. Calculate the support force on a person of mass 65 kilograms at the highest point on the ride. So the reaction force from the floor would normally be to support the weight of the person on the ride, but at the top point of the ride you always feel a little bit lighter than you normally do, and that's because the reaction force is not pushing on you as hard as it normally does, because a portion of your weight is supplying the centripetal force, so we would be subtracting mv squared over r, the centripetal force in this circumstance. The information hidden from us is the velocity, and that can be calculated using the once all the way around the circle, so the circumference divided by the time period the time taken to do one complete full circle. Substituting that into this equation, we end up with the reaction force would be the weight of the person subtract the centripetal force, which is going to be 2 squared is 4 times m, that m, times pi squared times r squared divided by r is just r, divided by the time period squared, capital T. And so the mass that goes in here is 65, and that also goes in here, 65. Gravity is 9.81. The radius of the fairground ride is 30 meters, and the time it takes to complete one full cycle of this ride is 80 seconds.